How do you find the domain of a composition function? We have two steps. You cannot skip step one. Find the domain of the inside or input function and keep any restrictions, meaning find the domain. Then we construct the composition function. We need to simplify it. Find the domain of that and then take those restrictions together. Let's just go through it step by step. Right, so I want to find f of g of x. F of g of x. So this is my input function or inside function. So step one says I need to find its domain. We discussed this in the last lesson. What is the domain of 2 over x? Well, x cannot be 0 because we cannot divide by 0. So that's the first restriction. Now, step 2, we want to construct the composition function. That means everywhere there is an x, what am I going to replace it with? 2 over x. Now I need to simplify that. How do I simplify that? Well, one way is to multiply the top and bottom by the common denominator of this whole expression by x over x and simplify. So those would cancel out and I would have 2. Here I'd have 2 plus 3x, because remember I'm multiplying this times both of those. And that looks a lot better. So that's my composition function. And now what is its domain? Again, we have to look at the denominator. That cannot equal to 0. So x cannot equal to negative 2/3. So we have to add the restrictions from step 1. So the whole domain of f of g of x is x cannot be 0, cannot be negative 2/3. And that is one way to write that answer. You can write it in interval notation, but that's just fine. That says it's all real numbers except 0 and negative 2/3. Let's do the second example. So I want to find f of g of x. Again, that's my input function, so I need to find its domain. Well, you may remember from the last lesson we have a square root, so what's underneath the square root has to be greater than or equal to 0. And so x is greater than or equal to negative 2. That means the only values x can be right now is only greater than or equal to negative 2. That's step 1. Now I have to do the composition function. So f of g of x says everywhere there is an x, I'm going to replace it with the square root of x plus 2. What's happening to that x? I'm squaring it. What happens when you square a square root? It goes away. So that's my composition function. What's the domain? Well, are there any restrictions here? No, this is all reals. Is that my final answer? No, because remember, x was only greater than or equal to negative 2. This offered no other restrictions. So the domain of f of g of x is greater than or equal to negative 2. In other words, you could write that as negative 2 comma infinity, and that would be in interval notation. Now we're going to do a little bit harder, not that much harder. Again, so we're going to do f of g of x, or f of g of x this way. So that's my input function. So again, this has to be greater than or equal to 0. So that's step 1. Find the domain of your input function. Step 2. Now we're going to find the composition function. So we're going to, everywhere there's an x, we're going to replace it with the square root of x minus 2. So we have the square root of something squared minus 1. And what am I going to put in place of that? That. That looks weird, so I'm going to square a square root, goes away. I'm going to collect like terms. So that's my composition function. what is its domain? Well, just like up here, this has to be bigger than 0, greater than or equal to 0. So it says x is greater than or equal to 3. I have this and I have this. Let's look on a number line. Here's 2, here's 3. This says x can be all of those numbers. This says x can be all of those numbers. Where do those overlap? What is the most restrictive domain? Only this part. So our final answer of the domain of f of g of x, that domain is x is greater than or equal to 3, or in interval notation written like that. So yes, we had to take that into consideration. This was the most restrictive, or the intersection of those two is still x is greater than or equal to positive 3. A little bit harder. All right, so again, we're finding f of g, trying to stay consistent here. So this is my input function. So what would be step 1? Would be to find the domain of that. So again, the denominator cannot equal to 0. So x cannot equal to 5 over 2. That's the easy part. Now, step 2 is I have to find f of g of x. That means everywhere there's an x, I'm going to replace it with that. So I have 2 times something minus 1 over something minus 2. And what is that something? Yuck. I need to simplify that. So the easiest way to do that, what's the denominator? The common denominator is 2x minus 5. So I'm multiplying by a form of 1, 2x minus 5 over 2x minus 5 to simplify that. So here, those would cancel, and I would be left with 2 times x plus 4 minus 1, and I have to multiply that as well. Over here, that would cancel, and I'd be left with x plus 4 minus 2 times that. Now here, you can't start canceling out those x plus 4s and stuff. You have to distribute and collect like terms. Keep going. So let's see. That's going to be 13 over negative 3x plus 14. So what is the domain of this? Well, we have to set the denominator equal to 0, or say can't equal to 0, and solve for x. So if I take the 14 to the other side and divide by negative 3, x cannot be that value. So what's the domain of f of g of x? It's x cannot be what we started out with in addition to 14/3. All real numbers but those two values. So the algebra is a little yucky, but it's not that bad. Now this problem is going to test your algebra skills. So step 1, we're going to find the domain of that. So the denominator cannot be 0. So we know that x cannot be negative 2. Now we're going to do that composition. So where there's an x, I have to put that. So f of g of x, or f of g of x written this way, which I prefer. So we have 1 over the square root of something minus 2. And what is that something? That. Now, how do you simplify that? Well, how about let's find a common denominator, which is x plus 2. Let's simplify that. Keep going. I'm going to collect like terms. Now I have 1 divided by a fraction. Well, 1 divided by a fraction means 1 times the reciprocal of that fraction. So we're going to get the reciprocal. And yes, it's over 1, but I don't really need to put that. So that is my composition function in its simplified form. But now I have to find the domain of that. That's what gets complicated. This is a review from the last lesson. So remember, x can't be negative 2. I'm going to write that again there. But what else are we restricted on? Well, this is a square root. So that means what's underneath the square root has to be bigger than or greater to 0. How do we solve that rational inequality? Well, in the last lesson we talked about the top. We set that equal to 0, looked at the bottom and said, hey, that cannot equal to 0, and we solved for x. And then we put those values on a number line. So we have negative 2 and negative 3 over 2. And since x cannot be negative 3 over 2, I'm going to put an open circle. But what about that? Should I fill it in or should I make it open? Well, in the last lesson, if this was just the problem, we would fill it in. But we know from the input function that x cannot be negative 2. So I'm going to go ahead and put an open circle. So I have already taken into account my first restriction. Now I'm going to test values. And where am I going to test values in? Here. So let's see, I'm going to pick a negative 3. I'm going to pick, how about negative 1.7? And I'm going to pick 0. So I'm going to put negative 3. And again, I'm going to test it in here. So I have negative 3 plus 2 over 6 minus 3. Is that greater than or equal to 0? No. So we don't want that part. Let's do the 0 part. That might be easy. We have 0 plus 2 over 0 minus 3. Is that greater than or equal to 0? No. Right? So now you might want to get a calculator. I have negative 1.7 plus 2 over negative 2 times negative 1.7 minus 3. Is that greater than or equal to 0? I'm going to give you a minute, let you do the calculation, and you should get a positive number. So yes, that part works. So that means my domain is from negative 2 to negative 3 halves. Notice I'm using parentheses on both ends because they do not include negative 2 because of the first restriction. They do not include negative 3 halves because it's in the denominator of a fraction. So this reviews everything from the last lesson and gives you more to think about how to find the composition of two functions. Then go back to the 2 steps and don't forget step 1.